Hello. What a lovely day to all of you. So in 1950, a British mathematician named Alan Turing asked a simple question. Can machines think? It was a radical question, not because of machines, but because we still don't fully agree on what thinking is. More than 70 years later, machines can write essays, diagnose disease, defeat world champions, hold conversations. And yet, one thing remains stubbornly unresolved. No machine is conscious. So today in this video, I want to explore why and why this question still matters, not just to scientists, but to educators, policymakers, and every human being on Earth. So the first part is what Turing actually meant. Turing didn't try to define consciousness. Instead, he proposed a workaround. The imitation game, now called the Turing test. If a machine could convincingly imitate human conversation, we would treat it as intelligent. So you got to notice something important. Turing avoided the question of inner experience. He replaced being conscious with appearing intelligent. So this move was practical, but it also set the stage for decades of confusion because imitation is not experience. Why I say this? A parrot can imitate language, a mirror can imitate depth. Neither is conscious. Part number 2, what computation can do extremely well. So let's be fair, computation is astonishing, and computers excelled at speed, precision, pattern recognition, memory. And modern AI systems outperform humans in many tasks. But here's the key insight. Computation manipulates symbols. Consciousness experiences meaning. A computer processes information. A conscious being feels information. So this difference is subtle but foundational. Now, part number 3, the hard problem of consciousness. So philosopher David Chalmers called it the hard problem, not how the brain processes information, but why there is something it feels like to be alive. Why does light produce experience, not just data? Why does pain hurt? No equation explains redness, sadness, and these are called qualia, subjective experiences. You can describe them, you can correlate them with brain activity, but you cannot compute them. You cannot compute the emotions. So part number 5, why simulating consciousness isn't creating it. Well, some would argue if we stimulate the brain closely enough, consciousness will emerge. But simulation is not duplication. A weather simulation does not get wet. A fire simulation does not burn. Likewise, a mind simulation does not necessarily experience. This is the core challenge, and consciousness may not be computational at all. It may be biological, embodied, and relational. And if that's true, no amount of processing power alone will create it. So part number 6. So the danger of confusing intelligence with consciousness. So here is the ethical risk. When machines appear intelligent, we are tempted to treat them as conscious. And when we do that, we overtrust them, we overshare them, we anthropomorphize, right? We anthropomorphize them. We misplace responsibility. Machines do not suffer, humans do. Assigning moral status to machines can distract us from human accountability. And part number 9, as in conclusion, why consciousness still matters. So let me end where Turing began. The question is not, can machines think? The deeper question is, what does it mean to be conscious at all? Consciousness is not speed, not intelligence, not data. It is awareness, experience, meaning. And until we understand that, consciousness will continue to defy computation. Not because machines are weak, but because being human is more than calculation or relatable computational thing, right? So thank you for watching, and I hope you learned something out of it from this teaching and sharing. And have a lovely day to all of you. And bye.